Hi guys, this is Christophe and I am going to introduce the Python library PyCSP3. This library allows us to write models of constraint satisfaction and optimization problems. Here, this is our website pycsp.org. So let's have a look at the full documentation. As you can see, you can get full details about each kind of constraints. In our case, we focus on 25 very popular important constraints. They permit to model any kind of problems. As an illustration, let's look at the page corresponding to the constraint cardinality. First, note that such pages can be downloaded as Jupyter notebooks and are very useful to understand the semantics of each type of constraint. In our case, for cardinality, we start by importing the library. Then we declare a one-dimensional array of variables called x. The size of the array is given by the name parameter size, and the domain of each variable is specified by the name parameter John. We can print the array to check that everything is okay. And next, we can post some constraints to be satisfied over the variables. Here, a unique constraint cardinality is posted. It forces variables in the array x to contain exactly one occurrence of the value 0, two occurrences of the value 1, and so on. This is specified by the name parameter occurrences, which must be given a dictionary. Once we have a model, we can solve it directly in the notebook. And to fully understand the semantics, we can even display all solutions that correspond to the full support of the constraint. At the end of the web page, we have some links to models involving the constraint cardinality. For example, the problem of social golfers. We unfortunately don't have time to explain the model, which is built step by step in order to fully understand it, but the result is shown at the end of the page. This model, with some appropriate data, for example, data given in a file, a JSON file. So this model with some data can be compiled in order to generate an instance in the format XCSP3. XCSP3, as described in our website xcsp.org, is a format that can be read by many solvers. We have some tools for parsing XCSP3 instances in Java and C++, and we also have tools for checking solutions. You can also find many series of instances on our website for many problems, and you can also participate to the annual XCSP3 competitions. For example, in 2022, we have a website with detailed results of the last competition. You can filter results, solvers, problems. You can even observe the behavior of solvers over time with many plots. Finally, note that you can also find many models in CSPLib. There are more than 60 models for classical problems on this website. That's all, folks. Thanks.